Now's the moment you've all been waiting for, the culmination of our work with linear functions in chapter 2. So we've seen intercepts of lines, right? We've seen slope and rate of change of lines. So now what we're going to finish up with in this unit is writing linear equations, which you've really been doing already from the beginning of the semester. Whenever we would write rules, they were really linear equations. We just didn't call them that, right? So what is going to be our normal equation that we're going to deal with? It's what is called as the slope-intercept, what is known as the slope-intercept equation of a line, right? Which is going to be y equals mx plus b, where m is the slope and b is the y-intercept. So that's why it's called slope-intercept equation, because it has the m, which is the slope, and the b, which is the y-intercept. So how do we write equations of lines? Simple. Just find the slope and find the y-intercept, plug them into the equation for m and b, leave x and y as x and y, and boom, you've got your slope-intercept equation. So let's say we had a problem where they said, write the slope-intercept equation of a line that has slope of 3 and y-intercept -2, right? So this is the line. The line has a slope of 3 and a y-intercept of -2. So what this means is 3 is going to be our m, and -2 is going to be our b. This guy has to stop commenting on my videos. He's just some robo guy. He's not even a real guy. So m is 3 and b is -2. So my slope-intercept equation is going to be y equals, now I know that m is 3 and b is -2. So all I'm doing is I'm just replacing m with 3 and b with -2. So y equals 3x minus 2. So what if they say, what's the equation of the line passing through 0, 4 with a slope of -1/2? Well, this actually is the same problem as we just had, because if we remember 0, 4, that actually is the y-intercept. Because remember when we did intercepts, we talked about the y-intercept was the value of y when x equals 0. So if x equals 0, that is the y-intercept. And then this is your slope. So all you're going to do now is, again, y equals mx plus b. M is -1/2. X stays x, and b is 4. So it's just y equals -1/2 x plus 4. So that's the simplest scenario, because there's really no work to do at all there. All right. Now if we move on to the second scenario here, what if we're given the slope and a coordinate? So in other words, let's say we're given a line that passes through 2, -4 with a slope of 2. What would we do here? We'd realize, hey, this point is not the y-intercept, right? That point is not the y-intercept. What it really is, it's just a specific value of x and a specific value of y that make the equation true. Now this, that is your m. So if we wrote y equals mx plus b, we don't have b, but we do have m, and we do have a specific value of x and a specific value of y. So what we can do is we can rewrite this equation, replacing y with -4, m with 2, x with 2, and b stays b because b is what we're trying to find. So now we're going to solve this mini equation here. So this is -4 equals 4 plus b. And then if we go to subtract 4 to solve this, we end up getting b equals -4 minus 4. Oops, sorry, I shouldn't have written that line underneath. I wasn't dividing there, right? Here it cancels, but -4 minus 4 more is going to be -8. So now I actually have my b value. So now together I can use my m and b to write the equation, which is just going to be y equals 2x, but now b is -8. So y equals 2x minus 8 is my equation there. So the last type of problem that we can have to find the equation of a line is if we're just given two separate points, right? Given two coordinates, neither one of which is the y-intercept. So let's say we have a problem that says find the equation of the line passing through, let's say, -2, 5, and 3, -5. Right, so we've got the line that passes through these 2 points. Now neither one, we don't have either of the slope or the y-intercept. But what we do know is we do have a formula for the slope that we saw, which was this, y2 minus y1 over x2 minus x1. So what we can do is we can think of this first point as being x1, y1, and this second point as being x2, y2, and we can find the slope that connects these 2 points just by plugging in and writing -5 minus 5, which isn't going to be 0, careful there, over 3 minus -2, right? -5 minus 5 is actually going to be a -10, and then 3 minus -2, right? This becomes 3 plus 2, so this is really 5. So the slope is actually -2. So this is your m. So m is -2. So now I just need to find b, but I don't know b yet, right? Because neither one of those points was the y-intercept. So what I do now is I make it like the problem we just did, right? Which said I can replace m with -2, and I can think of either one of these points, -2, 5 or 3, -5, as my x and my y, and I can now solve for b, right? So it doesn't matter which one I choose, I'm just going to use the first one. So I replace y with 5, I replace m with -2, and I replace b with -2, and I'm trying to find b. I'm sorry, I try to replace x with -2, and I'm trying to find b. So 5 equals -2 times -2 is 4, plus b, and now if I subtract 4 on both sides, I end up with b equals 1. So this was the other thing I needed, right? My y-intercept. So now I have my slope and my y-intercept. So once I have both of those, I just combine them to create my equation, which is y equals -2x plus 1, right? These two things combine to allow me to write the equation of the line. But I need to actually write y equals. So it's y equals -2x plus 1. So again, that's the things that you want to keep in mind, right? You always need an x and a y when you're writing the equation of a line, right, in the slope-intercept form. So x and y stay x and y. You just replace the m and the b with their specific values.